Okay, so we are on page 46, and we have just that last part to do, part number 3. And it says solve with calculator. And this means that we are in radians. Okay? We are in radians. So let's all set our calculator in radians right now. So that when it comes time to type it in, we'll be in the right mode. All right, so everybody's in radians. All right, but we can't go to the calculator just yet. Because what we have to figure out is, if the tangent is 1.75, Gavin, turn your camera on, please. We have to figure out which quadrants that could be. Okay? So who can tell me, that's a positive number. Who can tell me, Gabe Jones, put your camera on. You guys, I need all your cameras on. We're not going through this all period. Get your cameras on. Who can tell me where the tangent is a positive number? Because even though I'm using my calculator, I need some help from my picture. So where is the tangent positive? Someone tell me.
Quadrants 1 and 3.
Quadrants 1 and 3. Julianne, that is amazingly wonderful. Tell me how you knew that I was going to have a positive tangent in quadrants 1 and 3.
Because with TOA, it's opposite over adjacent, and the opposite and adjacent are both positive in quadrant 1, and they're both negative in quadrant 3.
Oh my gosh. Did you hear what she said? That is exactly the way all of your brains should be operating right now. Where is the tangent positive? Quadrant 1, positive, positive. Quadrant 3, negative, negative. Okay? Now, because we're using our calculator, you don't need to like label sides and do all that stuff. We're going to go straight to the calculator now, and we're going to find this angle, which is simply secant tangent 1.75. That's how you find the angle. So secant tangent 1.75. And this angle is 1.05 radians. If you were in degrees, it would be like 70 or something. I don't know. But that it's in radians, so it's 1.05. Your calculator took care of that for you. Now, if that one's 1.05, this one's 1.05. When you have multiple triangles for the same problem, they are all identical. So you only need to find the angle once. Now, your answers must be measured in standard position. So that means this is one answer. So one of your answers is 1.05. But the other answer is this. Up and all the way around to that line in quadrant 3. How will we find the measure of that angle all the way around to all the way around to down here? Well, peeps, how far is it from here to here? Well, in degrees it's 180, but I'm in radians. So I won't say 180, I'll say what?
Pi.
Pi. So this is pi. So from here to here is pi. And then I got to go 1.05 more. So won't I just do pi plus 1.05? So use your pi button. Pi plus 1.05 is 4.19. So the two answers to the problem are 1.05 and 4.19. All right, directions are the same. This time we have cosecant equals 7/3. So before we begin, well, first of all, we got an issue. I don't have cosecant on my calculator, right? So if the cosecant is 7/3, what's the sine?
3/7.
Yep. All right, so now I can deal with it. Where is the sine a positive number? Certainly in quadrant 1. Everything's positive in quadrant 1. Where else is the sine positive?
Quadrant 2.
Yes, very excellent. Who said that?
Colin.
Thank you, Colin. Now, how did you know the sine was positive in quadrant 2?
Because the y is positive.
Exactly. Oh my gosh, you guys are on fire today. Last period of the day on Friday, and you are on fire. The sine is associated with y, and y is positive in quadrant 2. Perfect. Now, I'm going to find this angle on my calculator. So I'm going to do second sine 3 divided by 7. Remember, to find angles, you do second, inverse sine, or tangent, or whatever. That's how you find angles. So in radians, that angle is 0.44. Well, this one's 0.44 also. Your angles must be measured in standard position. So one of them is 0.44. Right here's where we start. This is 0. That's 0.44. The other one, though, is all the way around to here. Right here. Watch my pen. This is the other one. How will I find that one? What would be the measure of that angle?
Pi minus 1.44.
Yes. Pi minus 0.44. Which is, whoops, wrong button. Which is 2.70. Now, let's make sure you understand how she did that. Here's pi. If I went all the way to there, it would be pi. But I stopped here. So this is 0.44 less than a pi. So pi minus 0.44. And there are the two answers to the problem. Got it? Okay, some nods or some of those little thumbs up pictures, something, so that I know you guys are still awake out there. Okay. Last one in this section. The secant is -3/2. Now, the directions are the same, so we're still in radians, and we're still going all the way around. I don't do secants because my calculator doesn't do secants. So if the secant is -3/2, then the cosine is -2/3. Would you agree with that? Now I need you to stay on top of this because this one's a little bit tricky. I want you to really pay attention to what I'm saying. First of all, where is the cosine negative?
2 and 3.
2 and 3. Because cosine is associated with x, and x is negative in quadrants 2 and 3. It's all very logical. Now, I'm going to go to my calculator, and I'm going to second cosine, but I'm not going to put the negative in because I already took care of the negative by drawing it over here, and I really just want to know what that angle is, the reference angle. So I'm going to type second cosine 2 divided by 3, and I get 0.84. if you put the negative in, you will not get the reference angle. And therefore, you won't be able to find your second answer. So don't put the negative into the calculator. You put the negative on the blackboard or on your paper by putting it in these two quadrants. Okay? Now, in this problem, is 0.84 an answer? No. This is the first answer. Remember, you're measuring in standard position, so you've got to start at 0. So how will I find my first answer?
Pi minus 8.4.
Yep. And then I'm going to find my second answer, which will be what? My second one, all the way around past pi down to here. What will that one
Pi
be?
plus 0.84.
Yep. And those are the two answers to the problem. So pi minus 0.84 and pi plus 0.84. So you should have gotten 2.30 and 3.98. All right, so quick recap, because we're switching gears completely here. When we're solving a trigonometric equation, first thing you got to do is figure out where your answers are going to be, which quadrants they're going to be. Then, if it's a special triangle, like a 30, 60, 90, you can do it without a calculator. But somehow you got to find the reference angle. So you can use a calculator to do that. And then you make whatever adjustments are necessary to get the actual answers. The only time the reference angle will be an answer is when you're in quadrant 1. If you're other places, you're going to have to make the adjustments. Okay? All right. Now, we got our calculators out. We're going to do a little graphing. I need everybody to follow directions, though. We're already in radian mode, so that's good. But I want you to go to your window and notice that 4.6 says sketch from negative 2 pi to positive 2 pi. So for x min, I want you to type negative 2 pi. And for x max, I want you to type 2 pi. Now, when you put those in, it's going to change it to a decimal. Don't worry, that's fine. And then there really is nothing standard about the y's. My calculator is set with them at -6 and 6. So let's give that a shot. Set your y min at -6 and your y max at +6. And we'll just see if that works. If not, we'll adjust it. So x min, -2 pi, x max 2 pi, because that's what the problem says. And then I'm just winging the y's, -6 to 6. All right, now I'm going to type in my equation. So I'm going to go up to y equals, where I always type in my equations. I can't see myself here. Yeah. So we're going to go to y equals. And then type it in exactly the way I wrote it. So you need to type a parentheses and then sign x and use your x button. Use your variable button, the same button you used before. You'll need to close the parentheses twice and hit squared. And then hit graph. Tell me what you got.
Bumps on the x-axis.
You just got bumps on the x-axis. That's exactly right. Did everybody get bumps on the x-axis? I don't know if you can see this or not. Did everybody get bumps on the x-axis? So instead of hills and valleys, you got all hills, basically. All right, let's type in the second one. X squared plus 2 sine x. Whoa. What's that look like? Kind of, sort of.
I got a big U.
Yeah, parabola type thing, right? Did y'all get some kind of parabola? Does that make sense? When do I get parabolas usually? What's in my problem when I get parabolas?
A square.
X squared. And I have x squared. And I'm adding a sign to it. But remember, the sign bounces back and forth between -1 and 1. So the sign is not a very big number. So you're taking your parabola and adding a small number to it. So that's why you still sort of have a parabola. Now, the first graph we did was what we call periodic. It repeated. It went bump, 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 bump. This graph, the second one, is not periodic because it doesn't repeat. It's just a parabola. One parabola. Not a whole bunch of parabolas, but just one. The first equation was periodic. The second equation was not. Okay. Now, problem 2 talks about if something is a sinusoid or not. What in the world is a sinusoid? Well, let's graph this equation. Let's graph A and see if we can get a sense, because A is a sinusoid. I'll just tell you it is. Then we'll talk about how I know. But let's graph it. So sine x, close the parentheses, minus 3 cosine x. Hit graph. Is the shape that you got like hills and valleys that are all the same size? In other words, the shape that you got is a sine curve. That is the shape of a sine curve. Hills and valleys that go up and down the same amount. That's called a sinusoid. Okay? Now, how did Mrs. Ford know before graphing it that it was a sinusoid? Well, I want you to look at this part of the picture, or this part of the equation. What is the period of the sine? Who remembers what the period of the sine is? Ay, 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 this is a biggie. What is the standard period of the sine and the cosine?
1.
Oh, 2 pi. The amplitude is 1, but the period is 2 pi. And right now, this conversation revolves around period. So the period of the sine and cosine is 2 pi. When you graph them, this is 2 pi. That's the period. So the period of this piece is 2 pi, and the period of this piece is also 2 pi. When the periods of each piece match, it is a sinusoid. Okay? So let me say that again. When you have one of these sums and differences where you got more than one function, you find the period of each piece, and if they match, it is a sinusoid. And the period is 2 pi. So for problem A, it's a sinusoid because these are both 2 pi, and whatever these are is going to be the period of the answer, or the sum difference. Okay? So now we're going to look at the next one. We're not going to graph this one. We're going to figure it out. We've got 2 sine x minus tan x. Well, what did we just say? What's the period of the sine?
2 pi.
Thank you. What's the period of the tangent? Be careful, it's different. Who remembers the period of the tangent? What?
No solution.
No, there's no amplitude. I'm just talking about amplitude. What's the period? How far is it from asymptote to asymptote? Pi. Yep. Do they match? No. Okay, they don't match. So this is not a sinusoid. So that's easy. If they don't match, it's not a sinusoid. But it is periodic, because if you add two things with a period, you're going to get something with a period. So here's how you find what the period is when they don't match. Keep in mind that what it means to have a period is every 2 pi it repeats. So this thing starts at 0, starts over again at 2 pi, starts over again at 4 pi. And when I say starts over again, what I mean is you have this, and then you have this, and then you have this. Every 2 pi, it's starting over again. This, and so on, forever. This one is starting over every pi. So it starts at 0, starts over again at pi, then 2 pi, then 3 pi, and so on. The first place that they both start over again is the period. So do you see how both of them are starting over again at 2 pi? It's like the least common multiple. They're both starting over again at 2 pi. So that is the period of the problem. So this one is not sinusoidal because the periods don't match. But the period of it is 2 pi. All right, I can see, even though your faces are tiny little blobs on the screen, I can see some confusion there. So let's look at the next one and see if we can clear it up. We have sine 2x plus 3 sine 5x. Now remember, any conversation in this section is about period, not amplitude. So see that number right there? We're not even worried about it. That's an amplitude number. That's a height number. We are concerned with these numbers. The period of a sine is 2 pi. But this one has been divided by 2. Remember how that number divides the period? So the period of this is actually pi. What about the period of this one? Well, it's supposed to be 2 pi, but it's been divided by 5. So the period of it is 2 pi over 5. Okay, is everybody with me? Okay, do they match? No. So therefore, is it a sinusoid? No. Because the only way you can be a sinusoid is if the periods match, and they don't. So that answers the first question and the second question. Now the third question, what is its period? Well, this one starts over every pi. So it starts at pi, 2 pi, 3 pi, and so on. This one starts over every 2/5. So it starts over at 2/5, 4/5, 6/5, 8/5, 10/5. I'm going to stop there because what's 10/5?
2
2 pi. So they are both starting over at 2 pi. So the period of the whole problem is 2 pi. It's the first one of these they both have in common. Mrs. Ford, is the period often 2 pi? It sure is. Not always, but it often is, because that's the standard period of these curves. All right. Pi sine 2x minus pi sine 3x. Now, these pi's out here in front do not bother me. I don't even think about them. I don't worry about them. Don't have anything to do with them because they're amplitude. I need this number and this number. So the period of this is 2 pi over 2, which is pi. The period of this is 2 pi over 3. Remember, the coefficient on x divides the period. Is it sinusoidal? Nope, they don't match. They're not the same. So, I need to find the period. So the period, this one starts over at pi, 2 pi, 3 pi. This one starts over at 2/3, 4/3, 6/3, which is
2 pi.
2 pi. I want you to look down. That was problem D that we just did, problem D. Look down at F right under that. Isn't F going to be exactly the same thing? Because even though there's more going on in the problem with pluses and minuses and stuff, aren't the coefficients on X the same as they were in D? And if the coefficients on X are the same, won't the periods be the same as they were in D? Do you know what I'm talking about, folks? So and look at problem F. The period of the first one's going to be 2 pi over 2, and the period of the second one's going to be 2 pi over 3. That's exactly what I just did. So the answer to F is going to be exactly the same as the answer to D. Would the pictures be different? Yes, but I'm not graphing them. I am simply determining their period. So F is going to be exactly the same as D. Now, what about E? What's the period of this first one?
One.
Yes! Thank you. 2 pi over 2 pi. Remember, period of a sine is 2 pi, or cosine, is 2 pi divided by this coefficient. So it's 2 pi over 2 pi, which is 1. What's the period of this one?
1.
Exactly. So since the periods are the same, this one is a sinusoid, and the period is 1. They both start over at 1. So it's a sinusoid, and its period is 1. All right, so 4.6, the part we do is a little bit short, so we just finished it. So that'll be an easy, I think, homework assignment for you to do. So 4-5 and 4-6 are both due on Tuesday. While I'm thinking of it, if you haven't yet brought in your cereal, Monday is the last day. Please bring it in during office hours, your cereal. We'd love to get some more cereal. Okay, here we go. 4.7. Who remembers what exact means? What does exact mean? No calculator. Put the calculator away. We're not using a calculator for at least the first part of 4.7. All right. Do you have your colored sheets handy? If you do, get them out. If you don't, write this down because I'm giving you some more pertinent information that really belongs on the colored sheet. Okay? This notation, now I know we have used that notation, but it was never part of a problem before. Now it's part of a problem. I mean, it's right there. It's written in the problem. When that notation is in the problem, there are rules that are very specific about where you're going to find your angles. Remember that problem A means find the angle whose sine is √3/2. There is only one such angle when you use that notation. So we're not going to set up the whole coordinates plane and look all around for where it is. There's only one. This notation means you are either in quadrant 1 or quadrant 4. So please add this to your pink sheet. And again, I need to emphasize that what I'm talking about is when that is in the problem already. Not when you decide you're going to press that button. That's different. When this is the problem, then you're only allowed to look in quadrant 1 and 4. When this is in the problem, you also are only allowed to look in quadrants 1 and 4. When this is in the problem, you are only allowed to look in quadrants 1 and 2. Oh my gosh, Mrs. Ford, why are the rules changing? You know what? I didn't get to make them up. This is just the way they are. You're putting it on your pink sheet. So to be clear, to make sure everybody understands what I'm saying, when you have problems like these in 4.7, number 1, where these notations are there already, you're going to draw triangles like you always have, but you're only going to draw them in these quadrants. Okay, so we got that written down. First problem is a sine problem. So I know I'm going to draw my triangle either in quadrant 1 or quadrant 4. Now, I want you to look at the problem and tell me, is it going to be both quadrant 1 and 4? Is it going to be just 1, just 4? What can you tell me about the angle whose sine is positive √3/2?
1.
Absolutely. Boys and girls, sine is opposite over hypotenuse. If I drew it down here, wouldn't that √3 have to be negative? And it's not. So this one is drawn in quadrant 1 only. The only options are 1 and 4 is not an option for this particular problem. Well, you should recognize that. We're doing this without a calculator. How big is this angle?
60.
Yep. Now, that is a degree measure, And we are supposed to answer in radians. So let's remember that pi is 180. And 60 is a third of 180. So this is actually pi over 3. 180 divided by 3. So since we are in radians, we'll say pi over 3. If we were in degrees, it would be 60. They are both correct. All right, let's look at the next one. Where do you think you're going to draw this one? Your options are only 1 and 4 because it's a sine. But this time it's a negative number. Where do you think we're going to draw it?
4.
Yeah. Kids, are we ever going to draw a negative in quadrant 1? Nope. Never. Sine is opposite over hypotenuse. Remember, hypotenuse is always positive. Remember, we're doing this with no calculator, so you should recognize that triangle. How big is the angle this time?
30.
Yep, that's a 30-degree angle. Remember, we're in radians, so 30 is a sixth of 180. So this is pi over 6. Now, do you think about it now, do you think pi over 6 is the answer to the question? Do you think 30 degrees is the answer to the question? No, because if you drew 30 degrees, it would be up here, wouldn't it? Isn't that 30 degrees? We're drawing it down here. So what are we going to say? Not positive 30, but...
Negative.
Yep. So the answer is negative pi over 6. These can be a little bit wild and wacky, folks. I get it. We got to stay focused. I promise I'm not going to talk all period. We got to get through a little more, and then I'll let you go. I know how hard it is. Been on Zoom all day. Yuck, 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 yuck. All right, look at your pink sheet. Where did we put inverse tangent? Either in quadrant
1 or 4.
1 or 4. So since that's a positive number, I guess I'll draw it in 1. Because I need opposite over adjacent to be 1 over 1. Tangent opposite over adjacent.
The angle is 45 degrees.
The angle is 45 degrees, absolutely. 45 is a fourth of 180. 60 is a third. 30 is a sixth. 45 is a fourth. Can our answer actually be pi over 4 this time, since we're in quadrant 1?
Yes.
Yes, it can. So the answer to the problem is pi over 4. In degrees, it would be 45 degrees. Okay. Now this one is wild and wacky because I know I'm allowed to draw it in 1 or 2. That's what you wrote on your pink sheet, hopefully. But this is going to be hard because adjacent over hypotenuse would be 1 over 0. Can I have a triangle with a side of 0? No, I cannot. So, what am I going to do? If I can't draw a triangle, what do I do?
Draw a line.
I draw a circle. I heard somebody say draw a circle. And the circle I draw has a radius of 1. It's called my unit circle. It has a radius of 1. And this is 0 and 90 and 180 and 270, just like always. But if the radius is 1, I'm going to start at the origin. If the radius is 1, I'm going to go 1 this way, which makes this point 1, 0. And then I'm going to go up 1, so that's 0, 1. And then left 1 and down 1. So if the radius is 1, I can actually label those points. Would you agree with me? Starting at the origin and going in 1 every direction. Okay. Now, look at your pink sheet since you got it there. Cosine is not only adjacent over hypotenuse, but isn't cosine also x over r? So this is where our circle helps us. All of these points have an x and a y, and r is automatically 1. We know r is 1. That's the way we set it up. So if we want the cosine to be 0 over 1, then don't we need x to be 0? So start right here. Start at 0 degrees. Is the x coordinate 0? No. How about up here? Is the x coordinate 0? Yes. So this is your answer. Because if you put x over r, 0 over 1, you get the right answer. Now, what angle is that up there?
90 degrees.
90 degrees, which is half of 180. So the answer to the problem is pi over 2. When zeros are involved, you can't draw a triangle. So when zeros are involved, you have to look at the circle, and you have to look particularly at these points because they have zeros in them. And then you have to find the one that has the 0 in the right spot.
Why wouldn't it be the bottom one?
Okay, it could be, but the rule is that we go in quadrant 1 and 2. Remember this notation? And if we're only allowed to be up here, then that one can't count. It would give me the same answer, but I have to work within the framework of the rules. Okay? And Alexis, we have these rules because our calculators are function machines. So when we type something in, we want there to be just one answer. We don't want 2 answers. We want 1. So a long time ago, some smart guys set up the rules so that there would be just 1 correct answer. And we just have to live with it. Okay? All right, next section. Get your calculator out. This is easy. We're just typing it in. It says decimal degrees. So go to mode, change it into degrees. And then just type exactly what you see. You do not need to draw a picture. You don't need to even think. You just type secant tangent negative 1.43. Did you get negative 55.03? That's it. Secant sine 0.761. 49.55. Uh-oh. I lied. I said you didn't even have to think, but you're going to have to think about this one because you don't have that button, do you? So I want you to stop a minute. This says, and you don't necessarily have to draw it, but it might help you. This says that there's an angle out there whose secant, so that's 1.98 over 1, whose secant, hypotenuse over adjacent, is 1.98 over 1. What does that mean about the cosine? What's the cosine of that angle?
1 over
Exactly.
1.98.
So this, friends, is what you type in. Secant cosine 1 divided by 1.98. 59.67. $59.67, everybody? All right, we're going to do the next 4 problems, and then we'll be done for the day. What's exact mean?
No calculator.
All right, so we got to put the calculators away again. And we are going to find the sine of the angle whose tangent is 0.1. Now, you can either leave that 0.1, or you can think of that as 1/10. I like to have a fraction, so I think I'll think of it as 1/10. What are my choices for drawing this according to my pink sheet? Quadrant 1 or 4. But it's positive, so it has to be in quadrant 1. You guys hang with me. I know you're tired of this. I know you are. We're going to get through this. Tangent is 1 over 10. That's what this says. Forget this for a minute. Just look in the parentheses. It says I have an angle, and the tangent is 1/10. What does that make the hypotenuse?
Square root of 101.
Pythagorean Theorem. 100 plus 1, 10 squared plus 1 squared. Perfect. Now, I haven't done anything with this. I started in the parentheses, and I drew a picture of that angle. Okay, right there it is. Now, what is the sine of that angle? Right there. What would the sine be? That's what the question says. What is the sine of this angle?
1 divided by root 101,
Yep.
which would be root 101 divided by 101.
Perfect. That's exactly right. So draw a picture of what's in the parentheses. Do the Pythagorean theorem to finish off the triangle, and then answer the question. All right, so the next one, draw a picture of what's in the parentheses. So my pink sheet tells me that inverse sines are either in quadrant 1 or 4. But since that's positive, it's going to have to be in 1. And opposite over hypotenuse is 2/3. That's what the sine is. The sine is opposite over hypotenuse. So this tells me, I'm not looking at this, I'm looking in the parentheses, drawing a picture of it. Opposite over hypotenuse is 2 over 3. All right, let's do the Pythagorean theorem carefully. Carefully. X squared plus 2 squared equals 3 squared. Remember, the hypotenuse is by itself. So what do we get for that third side?
Root 5.
Perfect. If you did not get root 5, do it again. X squared plus 2 squared equals 3 squared. You have drawn a picture of what's in the parentheses. Now answer the question. What's the secant of this picture? What's secant?
The opposite of cosine, which is 3 over 5, which would be 3, 5.
You got it. 3 square root of 5 over 5. 3 over square root of 5. 3 root 5 over 5. Okay, we have 2 more problems. Hang with me, folks. You can do this. And then I promise we'll be done. Abby Coe. You out there?
Yeah.
All right. I'm going to draw that this is a positive. With this notation, anything that's positive is drawn in quadrant 1. That's where positives are drawn. Tell me about cosecant. What is the definition of cosecant? Look on your pink sheet. If you're talking, I can't hear you.
R over y, or hypotenuse over opposite.
Exactly. So hypotenuse is 3 and opposite is 2. I think we just had that triangle, actually. So now we're going to find our third side. We're going to do our Pythagorean theorem. Gabe Jones, what's my missing side down here doing the Pythagorean theorem? X squared plus 2 squared equals 3 squared.
Is it 5?
Square root of 5.
Square root of 5?
Yep, square root of 5. All right, Ben, I need the tangent. I've drawn the picture. Remember, the parentheses gives me the picture. I've drawn it. Now I need the tangent of it. So, Ben, what's the tangent?
That would be 2 over 5.
2 over the square root of 5. Perfect. And 2 over the square root of 5 is 2 square root of 5 over 5. That's it. Tangent is opposite over adjacent. All right. One more. Last one. Oh my gosh. Last one. Find the cosine of the angle whose sine is -1/5. Now, be careful. That's a negative number. I will not be drawing it in quadrant 1. Correct? Because I don't draw negatives in quadrant 1. So look at your pink sheet. Remember, we're only looking at the parentheses right now. Where do these get drawn?
Quadrant 4.
Yep, if it's not 1, it's 4. And the opposite is -1, and the hypotenuse is 5. So do your Pythagorean theorem. And tell me what you get for the missing side. Abby, you working on it? Abby Rotz?
Yes, I'm working on it.
Okay. Pythagorean theorem. Don't overthink it. X squared plus 1 squared equals 5 squared. X squared plus 1 equals 25. X squared equals 24. So what's X?
2 root 6.
It's the square root of 24, which actually simplifies to 2 square root 6. Now, that is a picture, all that we just did is a picture of the parentheses. Now we need the cosine. So look at your angle. The cosine is adjacent over hypotenuse. So the answer will be 2 square root 6 over 5. All righty, that's it. We'll finish up next time. I think we'll probably finish our notes next time. And so that means that we'll be having a test either the end of next week or the very beginning of the next week. Okay, so plan accordingly. Good luck to our singers. Show choir competition this weekend. Go team. And the rest of you, have a wonderful weekend. God bless you. Be safe and smart.
Thank you.
All right, we'll see ya.
Yeah.
Bye-bye.
Thank you.